Hello guys, welcome to lesson 12, basic trigonometric identities, power reducing identities. So what are power reducing identities? So basically power reducing identities are identities, okay, used to simplify expressions containing powers of 2. So for example, sine squared u. So we have this expression here, or identities here. Okay, so cos squared u, it's 1 plus cos 2u over 2. Tan squared u equals 1 minus cos 2u over 1 plus cos 2u. Okay, so generally these identities were derived from, okay, from we can use half angle identities. Okay, so if you can remember in our previous lesson, so if this u here is actually theta over 2, so this becomes theta. Okay, however, if it's 4, okay, it becomes 4 theta over 2, which is actually 2 theta. So if this becomes 2 theta here, so theta here is u is actually theta. Okay, so u is actually theta. So it is derived from the half angle identities. So let's try to apply. Let's have example number 1. We have to rewrite a sum of first powers. So we're going to reduce sine to the power of 4x in such a way that we have an expression containing a degree of 1. Okay, so reviewing, sine to the power of 4x is equal to sine squared x to the power of 2. Okay, here we can now apply our power reducing formula. So sine is sine squared u is 1 minus cos 2u over 2. So this is 1 minus cos 2x over 2. Okay, so this is still squared. So if it's squared, we're going to multiply it by itself. Cos 2x over 2 times 1 minus cos 2x over 2. Okay, so here we have a square of a binomial. So we can rewrite this one as 1 minus 2 times 1, which is 2 cos 2x, plus the square of the last term, which is cos squared 2x, all over. So 2 times 2 is just 4. Okay, so are we finished yet? So we're not yet finished. So we can actually simplify this further as 1/4 minus, so 2 divided by 4, so we have 1/2. So this is cos 2x over 2 plus cos squared 2x over 4. But take note, cos squared 2x, we can still apply cos squared u. So we can have 1/4 minus cos 2x over 2, so plus, so this becomes 1 plus, okay, so it's 1 plus cos, so our angle here is 2x, so it becomes 2 times 2x, so this becomes 4x over 2 all over 4. Okay, so 2, we have 2 here, then it's divided by 4, so this becomes 8. So we have our final answer being 1 over 4 minus cos 2x over 2 plus 1 over 8. Okay, so I just separated 1 plus cos 4x over 8 plus cos 4x over 8. So we have 1/4 1/4 plus 1/8. So we have 8 divided by 4 is 2. So we have 2. Then we have plus 1. So this is equivalent to 3/8. Actually, it's exact. So yeah, 3/8. 1 over 4 plus 1 over 8. So yeah, it's 3/8. So minus cos 2x over 2 plus cos 4x over 8. So this is the final answer. So there are no exponent greater than 2 or greater than 1. So in this scenario, so we have cos 2x plus cos 4x. Okay, so our only goal is to have a sum of first powers. So let's go to the next example. Let's have example number 2. We have cos to the power 4 x. So again, same scenario. So we have cos squared x squared. Okay, and we know that cos squared x is 1 plus cos 2x over 2 squared. Okay, then distributing the square, so we'll have square here. Okay, and of course square here also at the denominator. So we have a square of a binomial, so we have 1 plus 2 cos 2x plus cos squared 2x all over, so 2 squared is 4. Then separate everything, so we have 1/4 plus cos 2x over 2 plus cos squared 2x over 4. But again, we know that cos squared 2x can be simplified further. So we have 1/4 plus cos 2x over 2 plus, so this becomes 1 plus cos, since it's 2x, so 2 times 2, so we have 4x over 2 all over 4. Okay, so again, this is equivalent to 8. 2 divided by 2 times 4 is 8. So we have 1/4 plus cos 2x over 4 plus 1/8 plus cos 4x over 8. So we have 3/8 plus cos 2x over 4 plus cos 4x over 8. And this is our final answer. So that's how you simplify using power reducing. So the only goal of power reducing formulas is to reduce the power. So that's why it's called power reducing. Okay, so that's examples 1 and 2 shows us how to reduce that power in such a way that our the degree of the highest exponent of the expression or the identity is 1. Okay, so in the next video we will be examining the last set of our identities, the product sum identities. See you there.